polynomials are any function of x that involve different whole number powers of x. Okay, any function of x that involve different whole number powers of x. So we have been looking at things like y equals 2x minus 3. That is a polynomial because it's a function of x and it's got whole number powers of x. Okay, in this case, the power of x is just 1. This is not a polynomial because that involves a power of x that is power of a half. It's not a whole number. We've been doing functions like this, and we're doing functions like x squared. That is another polynomial. Again, it's a polynomial with a power of x of 2. Okay? But if we want to consider the general form of polynomials, this is how we would write it. Okay, let me explain what this is saying. So a polynomial is a function in x with different whole number powers of x with some coefficients out the front as well. What do we call each of these things? This is important terminology that we need to know. This part here is called the degree of the polynomial. So whatever the highest power of x is the degree of the polynomial. So for a quadratic, what is the degree of that polynomial? It's 2, because the highest power is x squared. For a cubic, what is the degree of the polynomial? 3. For a linear function like this, what is the degree of that polynomial? 1. Okay? That's the degree. The next thing we talk about then is this part here, which we call the leading coefficient. The leading coefficient is the coefficient in front of the highest degree term, the highest power term. Okay, the leading coefficient is the coefficient in front of the highest power term. Remember the coefficient? What that means is the number part in front of a pronumeral. Sometimes it's a number part that's actually not written as a number. It could be like pi, which is a number, but we just represent it with another kind of symbol. But it's whatever the number part is. And then all together, we call these things, to all of those, the leading term. So we've got a degree, which is the highest power of x, with the leading coefficient, which is the coefficient in front of that highest powered term, and the whole term we call the leading term. A few other things that we can talk about. This 1 on the end, which has no power of x, or we might describe it as x to the power of 0. Okay, this one here we call our constant term. When we come to draw polynomials, what does that constant term tell us? Y-intercept. Yeah, okay, so the constant term is also the y-intercept of a polynomial. When it comes to drawing, that's a really helpful thing. And because the y-intercept is where x equals 0, and so when you put x equals 0 into all these other terms, they all become 0, and all you've got left then is that constant term. And something important to realise is this, that whatever the degree is, whatever the degree of a polynomial is, will tell us how many roots there are of that polynomial. However, sometimes those roots may not be all real. Okay, and that's where we get onto stuff with extension 2 maths. But for the time being, what that also tells us is that it does give us the maximum number of roots. So if we have a polynomial with degree of 5, the maximum number of roots is 5. Okay, it may not have all of that because some of them may be not real roots. Okay, so we may not be able to draw those at our level of maths. all those 5 roots, or calculate those 5 roots. But we do know that it can't have 6 roots or 7 roots. If the degree is 5, it can't have 6 or 7 or more than that. Okay? The maximum number of roots is the degree. The maximum number of real roots is the degree. Okay. So as we've just done with those examples just previously, we can draw any polynomial we want if we can factorise it. And that's obviously the difficulty that we have with very high level, high degree polynomials, but we can't always do the factorising easily, and we do some of that in Extension 1 Maths. But if it is written in factorised form for us, then we can draw it. So if we had a function, that looked like this, we can draw that. Okay, if we had a function that looks like that, we can draw that. Let's do that. I'll pop this over here. Let's draw that. And we're going to use the same skills we've just been practicing. We're going to identify the different roots of that equation. It's in its factorised form. We can do the roots. What are the roots of that equation? What are the roots of that equation? Sorry? Positive 3 is one of them. What else have we got?
Negative 2.
Negative 2.
And 1. Positive 1.
Negative 2 and positive 1. What can you tell me about those other 2 roots, the negative 2 and the positive 1?
Double.
Yeah, so they're double. Yeah, they're term ones. So that's right. So they're double roots. Okay, the positive 3 root, because that is just, there's no squared on that bracket. That's a single root. That's a double root. That's a double root. Okay, and so we're going to identify these as double roots here, and that is a single root. Okay, so I'm drawing that flat line to say that I'm going to touch it, and then this one's going to cross. But which side, does it come down like that and touch like that? Or does it come up and touch like that? Which way do we do? Which way does it go?
Up.
Okay, so what we do is we go back to this and go, well, let's look at all these x terms. We multiply this x and that x squared and that x squared. We're going to have still a positive x. What degree is our 5? Yeah, degree 5, isn't it? Because there's an x here and an x squared here and x squared there, multiplied all together, becomes x to the power of 5. And so it's a degree of 5. That is an odd number polynomial. It means it starts in one quadrant and finishes in the opposite quadrant, or this way. Okay, but which way is it? It's a positive one, so it's going to start bottom left and go top right. Okay, so if I know it starts bottom left...
positive because it's going up the y-axis?
It means positive, as in the leading term here is going to be positive. That's why it's called positive. Okay. It's actually going to cut the y-axis in the negative.
Yeah, but like...
Okay, we call it positive because this leading term is positive. And I guess in a general sense, we're going in a positive gradient, kind of in a big scale from bottom to top. Okay, we call that positive. Okay, and so it's going to come down here, it's going to touch there, it's going to go back up and touch there, and go back down and go up and cross there. Okay? There's a piece of information missing. What is it?
Y.
The y-intercept. How do we figure that out?
Negative 2 times.
So we're just going to put a 0 into here. Okay? And so the intercept f of 0 equals negative 3 times 2 squared times negative 1 squared. Okay, so I've just made all of those x's into zeros. And so I've got, let's do these ones first. That's positive 1 and positive 4. That multiplied together makes 4 times negative 3, negative 12. Go across down here at negative 12. Okay, done. Okay. So it's nice and straightforward to be able to draw a polynomial when we've got it in factorised form.